Hi, and welcome to this lesson on the Python type hierarchy. Now we're only going to cover a subset of this hierarchy, and in particular this is the subset that we're going to cover in this course in quite a bit of depth, along with some other things as well. So we can start with numbers. Numbers are something we use, all the time in programming, and we can divide numbers up into two different sections: integral numbers and non-integral numbers. And by integral numbers, I mean things like integers, right? 1, 2, 3. But we also have Booleans. Booleans are actually also integral numbers. They're actually integers. In non-integral numbers, we've got a few more. Floats is probably the most common one. So if you write, a equals 3.14, that 3.14 is a float, which is implemented as a double in the underlying C. We also have complex numbers. Complex numbers, remember, are numbers that have a real and imaginary part. So we'll cover that, not really in depth. This course is not about complex numbers, but they are actually implemented in Python. We'll also look at decimal numbers. Now, decimals and floats kind of are used for the same thing, to represent real numbers that are not integral numbers, like 3.14. But it gives us a little bit more control on the precision of the number. Right? And there's different ways that precision is implemented between decimals and floats, and we'll cover that in some detail in a later course. Fractions, well, fractions is just basically your rational numbers, 1/3, 1/5, 1/8, 20, 17s, things like that. That's an interesting way of dealing with numbers, because let's say you deal with a number like 1/3. Okay, that's a rational number, and it has a value, a very specific value, 1/3. But if you try and represent that as a float or even a decimal, then you're really looking at 0.333 recurring, and we cannot represent that exactly in the programming language that we're using, in any programming language, because we don't have an infinite number of precision, right? We don't have an infinite amount of precision to store 0.333 recurring, which is an infinite, recurrence. So if we have to really deal with exact numbers, so if we want 1/3 plus 1/3 plus 1/3 to be precisely equal to 1, then we need to use fractions. The next part are collections. Now, collections can be broadly divided into three different parts. We have sequences, sets, and mappings. So under sequences, we can further subdivide that into mutable sequences and immutable sequences. And the ones that we'll cover in this course are lists, which are mutable sequences, and tuples, which are immutable sequences. They're essentially the immutable variant of lists. But strings is also a sequence type, and it is also an immutable type. Then we have sets. Now, sets can also be broken down into mutable and immutable. And in this case, we'll cover sets, which are the mutable sets. And we also have something called frozen sets, which are the immutable equivalent of sets. And lastly, we'll look at dictionaries. Now, dictionaries and sets, we'll see later, are actually related. They're actually implemented very similarly. Both sets and dictionaries are basically hash maps. The only difference is that sets are not key value pairs. It's basically like having a dictionary that only has keys but no values. So we'll look into that in a lot more detail in a later section. Then we also have something called callables. Now, what are callables? Well, callables are anything that you can invoke, anything that you can call. So like a function, for example. A function is a callable. So obviously, user-defined functions. Then we have generators, which are things that we can use to do iteration. And we'll get into a lot more detail about generators in a later class. Then we have classes themselves. Classes are callable. We have instance methods, which are just functions, but they're, inside a class. So they become instance methods once the class gets instantiated. We also have class instances that are actually callable. You can define this method here, dunder call dunder, that allows the class to become callable, the object or the class instance to become callable. And we'll get into that again in a lot more detail in the object-oriented section. And then you have built-in functions, right? Python has a lot of built-in functions like len, to get the length of a sequence, for example, open, if you want to open a file. You also have built-in methods. And really, they're no different than instance methods. But for example, if you have a list, well, lists have an append method, so you can append an element to the end of the list. These are all callables. And then we have these things hanging out there that kind of are, out on their own, and they're singleton objects like none that we've seen before, right? None is an object that exists, and whenever you set a variable to none, it always points back to the same memory address that we have for the none object. We also have something called not implemented. We'll take a look at that in more detail when we do object-oriented programming. And then we have the ellipsis operator. Again, we'll look into that in detail when we look at sequences and strings and lists and so on. It can be used for slicing. All right, thanks for watching, and I'll see you in the next video.